Welcome to This Explainer. Today, we're diving straight into the highly unexpected origins of the digital world that you and I use every single day. If someone asked you to trace the roots of the modern internet, you'd probably look toward computer labs, right? Or engineering departments. But as we're going to see today, the actual foundation of our digital lives comes from a totally different and much older profession.
$20 trillion. Let that number sink in for a second. That staggering figure represents the immense, real-world economic value created by the Internet's foundational structure and digital asset technologies. That is a massive amount of economic weight resting purely on the core language of the web. But it really begs a fascinating question.
So where did the Internet's fundamental language actually come from? We naturally assume that mathematicians, computer scientists, and software engineers basically built the web from scratch, right? Picture folks sitting in dark rooms just typing ones and zeros. But the actual truth? It's far more surprising. Get this. It was actually built on traditional legal drafting techniques. Seriously, the very DNA of the web is based on jurisprudential techniques. It's just a fantastic historical twist. The whole information architecture that allows you to read a web page right now, it wasn't born from pure mathematics. It was actually born from the meticulous way that lawyers have drafted, modified, and tracked contracts and subclauses for centuries.
Section 1. Meet Charles Goldfarb, the legal engineer.
The crucial point of this whole mystery really begins with one incredibly unique innovator who operated right at the intersection of library science, law, and early IT. We're talking about Charles Goldfarb. Now, Goldfarb earned the legendary title of the grandfather of the internet, but get this, he didn't do it by writing standard computer code like we think of it today. Nope. He did it by looking closely at how lawyers organize complex information. He saw that the legal profession had already spent hundreds of years figuring out exactly how to logically structure documents, clauses, and conditions. And he realized something brilliant. This existing legal framework was the absolute perfect blueprint for organizing digital information.
Section 2. Red lines to markup language.
This right here is where the bridge between the law firm and the computer lab is officially built. Think about traditional legal redline drafting. Lawyers using red pens to track changes, nest subclauses, and define logic in a paper contract. Now compare that directly to computer markup language, which uses tags, nesting, and structural formatting. Goldfarb literally translated those physical red pen marks into digital tags. A nested subclause in a paper contract seamlessly became a nested tag in computer code today. Think of how a specific section of a contract is bound by introductory and concluding legal phrasing. Well, that directly maps to exactly how we use opening and closing structural tags to define a body of text in code today. It's a total game changer.
This exact translation resulted in GML, or Generalized Markup Language. And by doing this, Goldfarb achieved something absolutely revolutionary. He separated the logic of execution from the material being processed. To put that into perspective, it's kind of like separating the structural blueprint of a house from the paint and furniture inside it. He essentially mechanized legal logic. He created a way for a computer to deeply understand the structure and relationships within a document, just like a lawyer understands the binding clauses of a contract, completely independently of the specific names and dates filled into it.
Let's break down exactly how that translation works. Step 1, you start with a normal, static paper document. Step 2, you apply the red line to track changes and nested clauses, the traditional legal review. Then, step 3, you translate those red lines directly into dynamic, digital markup tags. This step-by-step translation process was massive. It shifted our entire societal mindset from just looking at static paper documents to actually building dynamic, structured, and interactive digital environments.
Section 3. The birth of HTML.
So how exactly did Goldfarb's legal engineering evolve into the websites we scroll through today? Well, you can actually trace the lineage perfectly. We go all the way from the analog legal drafting of the pre-1960s straight to Goldfarb's GML in 1969. That directly inspired the creation of modern HTML in the 1990s, which leads us right up to the present day and our $20 trillion web. Every single web page today is essentially a descendant of a legal document framework, evolving seamlessly across the decades.
Now, this framework also solved a massive debate in computer science. In coding, you have imperative logic, which is telling the computer exactly how to do something, step by step, but you also have declarative logic, which just defines the final outcome, like simply commanding, make this text bold, without explaining how. Well, because legal vagueness is sometimes a feature, and strict precision is sometimes required, Goldfarb's markup language was perfectly designed to handle both imperative and declarative commands at the exact same time. The law absolutely required that flexibility, and so the Internet inherited it.
Section 4. A $20 trillion legacy.
This crossover created a massive paradigm shift. It turns out, law and programming are not opposites at all. Think about it. In law, you design a system beforehand in a contract, and when the parties execute their duties, it's actually called a performance. It's kind of like actors fulfilling obligations on a stage. Now, over in software, you do the exact same thing. You design a system beforehand, you hit play, and the computer executes a runtime. Both fields literally involve designing a deterministic system in advance, hitting play, and watching the performance execute from start to finish.
And you know what? Goldfarb wasn't alone in this endeavor. The legacy of legal engineering just kept expanding. While Goldfarb digitized redlining into markup language, innovators like Nick Szabo came along later and designed smart contracts. Szabo figured out how to hardcode the traditional legal requirement of consideration, which is just the actual exchange of value, like money for a service between two parties, straight into decentralized networks. We even see standard legal clauses mapping perfectly onto computer Boolean logic. You know, those true and false gates that route information. The code is basically just a brand new medium for the contract.
So the ultimate takeaway here is perfectly captured by this idea of applying jurisprudential techniques in information technology. The architecture of our digital world was quite literally forged by translating the meticulous, logical rules of law directly into technology. The Internet isn't just a giant calculator, guys. It is a globally scaled, mechanized legal document. How crazy is that?
Which leaves us with this final, really fascinating question to ponder. As we continue to rapidly build artificial intelligence and automated systems, what other modern technologies might just be ancient analog professions in disguise? It really makes you wonder what other hidden historical roots are quietly powering our future. Thank you so much for joining me on this explainer. I genuinely hope this changes the way you look at every single web page you open from here on out.